Magnetic field of Ampere's law, detailed explanation. Ampere's law, Ampere's circuital law, is one of the fundamental laws of electromagnetism. It describes the relationship between electric current and the magnetic field produced around that current. One statement of Ampere's law states, the line integral of the magnetic field around any closed path is equal to mu times the total current enclosed by that path. Mathematically, equals 0 where, B equals magnetic field, Tesla, T, dl equals small length element along the closed path I closed equals current passing through the closed surface mu equals permeability of free space 0 equals 4 times 10⁷ physical meaning when electric current flows through a conductor, it creates a magnetic field around it. Ampere's law tells us that the strength of this magnetic field depends on the amount of current enclosed by the circular path. The magnetic field lines form closed loops around the current-carrying wire. Magnetic field due to a long straight current-carrying wire. Consider a long straight wire carrying current I. The magnetic field forms circular paths around the wire. Using Ampere's law, equals 0 because the magnetic field is constant on a circular path, equals 0 the circumference of a circle, equals 2 therefore, 2, equals 0 so, equals 0 2 meaning, magnetic field increases when current increases. Magnetic field decreases when distance from wire increases. Direction of the field is given by the right-hand thumb rule. Right-hand thumb rule: if you hold a current-carrying wire with your right hand, thumb direction of current, I, curled fingers direction of magnetic field, B, this gives the direction of magnetic field lines around the conductor. Magnetic field inside a long solenoid. A solenoid is a long coil made of many circular turns of wire. When current passes through the coil, a strong uniform magnetic field is produced inside. For a solenoid, equals 0 if the solenoid has, n equals number of turns per unit length I equals current then, equals therefore, equals 0 cancelling L, equals 0 properties of solenoid magnetic field 1. Inside the solenoid, equals 0 magnetic field is, strong uniform parallel to the axis 2. Outside the ideal solenoid, 0 because magnetic fields cancel each other. Applications of Ampere's law 1. Electric motors. Ampere's law helps understand the magnetic field produced by current-carrying coils. 2. Electromagnets. Solenoids use Ampere's law to create strong magnetic fields. 3. Transformers and electrical devices. Magnetic fields produced by currents are analyzed using electromagnetic laws. Key points to remember: current produces magnetic field. Magnetic field forms closed loops. Only enclosed current contributes to Ampere's law. Direction is found by the right-hand thumb rule. Ampere's law is one of Maxwell's electromagnetic equations. Short YouTube explanation line: according to Ampere's law, the magnetic field around a closed path depends on the current enclosed by that path. It connects electricity and magnetism and explains how current creates magnetic fields.